weak acid, what did you say about it?
Okay, so with a weak acid, when you have it going to the equivalence point, when you have equal quantities of your weak acid and equal quantities of your strong base, what happens is you form the water like normal, but we don't
Right.
care about water because it's not part of the reaction. But then you form a salt that's basic
Okay,
because of the acetate ion that's there.
so, okay,
Does that make sense?
yeah. So if you have a weak base, it'll end up being acidic.
Yeah, so if we did something with an H3, HCl, we end up getting H2O and ammonium chloride. Oh, no, it's forgetting something.
Okay.
That doesn't make sense. Okay. So now, this ammonium chloride, which will separate out in this new aqueous solution that we have at equilibrium. It's going to separate out into ammonium, and chloride.
Mm-hmm.
Chlorine,
This is gonna, doesn't
chloride,
even matter.
it doesn't matter.
Yeah.
It's just basically a spectator ion. But this ammonium is a weak acid because it's the conjugate acid of a weak base.
Ammonium's a strong, I thought ammonium was a strong acid.
It's a strong weak acid. Conjugate acids run on a different set of strengths.
Okay.
So when you have a weak base, that means you have a strong conjugate acid. But if you have a strong base, that means you have a weak conjugate acid. So there's,
So isn't ammonia a weak base?
It is.
So it would be a strong conjugate acid?
we can actually figure this out by what I mean, by what I'm trying to explain. So the Kb of ammonia, you know what it is?
Nope.
It's basically, it's the basic form of acetic acid. It's 1.8 times 10 to the negative fifth. Which means our Ka for ammonium would be 5.56 times 10 to the negative, what was it, 10th?
Yeah.
10th. So that's a weak acid though. It's
Okay.
extremely weak acid. But compared to something like sodium, which would be something even smaller than this, it's a strong conjugate acid.
Okay.
So that's where the kind of two different strengths will come in.
Okay, that makes a little bit of sense.